Hello, I'm Dave Blinky, Regional Manager of Boise Cascade Southern Operations. I'd like to welcome you to view a very exciting tape on total quality. Here at the DeRidder Mill, we have been working with the 8-step process for improvement and have used this process in several major areas. One of these areas is groundwood optimization. Through the efforts of the Groundwood Optimization Task Force, we have realized a $1.5 million annual wood cost savings. This is an exciting tape, and I know it's going to get your attention. Without me saying much more, here is Chris Nelson to introduce the rest of the program and give you an overview of Southern operations. Thank you.
Dave, thanks for those comments. Boise Cascade owns and operates a pulp paper mill in DeRidder, Louisiana, which manufactures 1,100 tons of newsprint and 1,200 tons of kraft linerboard on a daily basis. Boise Cascade also owns and manages 750,000 acres of timberland, which supports a paper mill, 2 plywood plants, and a sawmill in Louisiana. 1,850 people are directly employed with the manufacturing and allied processes, with another 6,500 folks involved in logging and process-related industries in this area. The paper-making process actually begins in the forests of southwest Louisiana and southeast Texas. This is where the raw materials are produced and eventually become the paper we make. With this as a short introduction, it's time for us to begin our journey through the 8-step process.
Hi, I'm Jim McKnight. Trees grow in different sizes and with different characteristics. Larger trees, like this one here, tend to have fewer limbs for a longer distance along the tree and can be manufactured into several different products, such as plywood, lumber, or even paper. Because these larger trees with higher quality characteristics can be utilized into these different products, they are more higher valued than smaller trees with more quality defects. Take this smaller tree, for example. It's not big enough to manufacture into plywood or lumber, but it is big enough to provide fiber for paper. Tops from larger sawlog trees are similar. They have so many limbs that they physically cannot be sawn into lumber or made into plywood, but they can provide fiber to make into paper. As mill technology has improved over the years, it's now possible to manufacture smaller, high-quality trees like this one into lumber and plywood. Just several years ago, a tree like this one could not have been made into anything but paper. Today, though, this tree is much more valuable for lumber or plywood than it is for paper. Boise Cascade has always used the smaller, lower-valued trees and saw timber tops to make chips for the linerboard process. But we've been paying a premium price for these smaller, high-quality trees because we have thought that these are what was needed to make quality groundwood pulp for the newsprint process. For many years, we have thought that this quality groundwood had to be a certain size and have basically no quality defects. In order to meet the demands of the groundwood quality specifications, the company was forced to compete for the same trees used for higher valued processes. The team that was formed to address this situation, known as the Groundwood Optimization Task Force, centered our attention on this goal: to optimize the entire groundwood system in order to minimize the cost and time necessary to provide a quality product to the groundwood mill. In the following few minutes, the members of this task force will describe what we did, what we discovered, and the impact to Boise Cascade's bottom line.
Hello again, everyone. Step 1 is create the environment. On September 27, 1991, our group selected the project we wanted to apply this process to, and 3 days later, we finalized the task force members. Our team members included myself, Judy Lassa, Jim McKnight, Mike Runge, Tom Lester, Tom Linder, Stuart Martin, Don Moses, Ward Crow, and Danny Smith. The Groundwood team encompassed several different areas, all of which had a stake in the outcome of the task force. The members of the team encountered problems with the Groundwood system on a daily basis and would benefit largely from the improvements. Over the last several years, the working environment between Southern Forest Resources and the Woodyard had improved due to a better communications, common goals, and a shared vision. There still remain areas of opportunity for continued improvement between the organizations, and this process certainly helped facilitate this. Likewise could be said between Mechanical Pulp and the Woodyard, which in many ways exhibited similar customer-supplier problems. In order to become familiar with each other's areas and challenges each person was up against, the group toured each area involved and were given the opportunity to ask questions and gain understanding. Over the first 2 months of this task force, through data collection, individual interviews, interdepartment communications, formal Qualpro statistical training, and team-building exercises, we clearly developed an environment of trust, mutual respect, and focused our energy to tackle one of the mill's major problems. In addition to gaining understanding of each other, the group felt comfortable that management supported the process and any experimentation required which might temporarily interfere with quality, production, and cost goals. Step 2, identify key measures and establish operational definitions. In the 8-step process, this step consumed a significant amount of time and yielded many of the most positive results of any of the other improvement steps. Here's Judy Lassa to take you through this step.
The first task was to flowchart the process. We all had a fairly comprehensive knowledge on pieces of the process, but no one really realized just how complicated the wood handling process was until we collectively agreed on the final flowchart. These flowcharts became a very important part of developing our experiments, trials, and decision-making process. The second task in Step 2 was to come up with operational definitions. The group went through descriptive paragraphs word for word and established quantifiable definitions for very vague wording. Definitions such as a cat face, how large is it, where is it on the log, and so forth. What constitutes blue stain? Is it 1 inch in length, 5 inches in length, or is it across the whole face of the wood? One of the definitions we were using in both the Groundwood mill and the Woodyard had very different meanings to each of the areas and had been that way for over 20 years. This did not become apparent until the group began discussing definitions. The last item covered in Step 2 was the key measures. The following key measures were established at the beginning of Step 2. Cords of the wood delivered by quality code. Total cords cut per day or Woodyard daily throughput. Third was the cords consumed by the Groundwood run per day. Cost in dollars per cord of groundwood, topwood, and chips. And lastly, and most importantly, the Groundwood matrix in the Woodyard. The Groundwood matrix in the Woodyard was a major driving force behind what type of wood is needed to be brought into the mill and the sorting requirements necessary to meet the Groundwood mill's specifications. The team established operational definitions for each of the defects in the matrix and began the journey of sorting through facts versus perceptions.
Step 3, assure capable and controlled measurement systems. Step 3 of the 8-step process is to assure capable and controlled measurement systems. Our team spent the majority of time on Step 3 of the 8-step process.
Hello everyone, I'm Danny Smith. The Woodyard basically had no consistent nor accurate measurement systems in place. Everything in the Woodyard was a series of estimates based on past history. Some of the major areas covered were the weightometer, which measures total cards chipped, was found to be pegged out over 100% the majority of the time. The weightometer was recalibrated. Each shift operator calculated Woodyard production using a different method. The procedure for calculating Woodyard production was standardized across all 4 shifts. After actual measurements, the average volume per jib crane grapple bite was found to be 17 cords, 43% more than previously estimated. A measurement study of groundwood quality tree length loads delivered to the mill showed that an average load contained 50 to 72% groundwood by volume. And now here's Mike Rush to tell you about the blind sampling process.
Thank you, Danny. A blind sampling method was used to determine the measurement error in the groundwood quality matrix. No explanation or new procedure was given to the operators other than the logs may or may not be removed at the end of each day. The results from each department were measured against a standard measurement system used by the forestry department. The results from the blind sampling showed a large difference between each department and against the standard measurement system. Some of the interesting discoveries that resulted from the blind sampling included matrix scores varied as much as 150 points plus or minus. Some operators count the most important defect only versus multiple defects per stick. Some operators always got a score of 750 when logs were piled up on top of one another versus lying side by side to view defects. Only the visible defects can be recorded. Which end of the log should be measured when taking the diameter? Some operators estimate 100 logs and don't actually count them out. We also hinted to the operators that we might use the same logs 2 days in a row, which we never did, and found several operators trying to duplicate the score that they got yesterday. In addition to the blind sampling, standard measurements were taken daily on a 50-log sample and scatter diagrams were plotted to determine correlations. The groundwood matrix was based on several perceptions such as broom ends increase shives, no correlation, cat face reduce unbleached brightness, no correlation, diameter of the wood affects strength properties, no correlation, knots affect pulp quality, no correlation. And now here's Tom Lester with the big night out.
Thank you, Mike. The last major area undertaken in the measurement step was what we call the big night out. The objective was to obtain accurate measures of a typical groundwood run. The team members plus helpers from Forest Resources and Groundwood TMP areas spent a night in the wood yard and counted sticks at various points to be able to calculate volumes. The ran began at approximately 8 p.m. and was completed at 3 a.m. that morning. Following information was collected. The results of the study showed that 868 cords were brought into the mill and weighed in at the scale house. The visual count taken by the team, plus the cords of wood that went to the chip pile, accounted for 866 cords, less than a 2-cord difference. Other significant findings included all of the cat faces were eliminated by the sort. 14,140 sticks were accepted to the groundwood pad during the run, but also 15,670 sticks were rejected to the chipper. We confirmed the weight per cubic foot of debarked wood. Before the wood yard sorted for groundwood quality, there was 56% of the sticks within specification. After the wood yard finished sorting, there were about 8% of the sticks within spec.
Several key measures no longer exist because of this project, and they include the Woodyard Department Groundwood Quality Matrix and the Scalehouse Groundwood Quality Matrix. In addition to the gross inaccuracy of this matrix, most of the key measures in the matrix were found to have no correlation with groundwood quality key measures in the Groundwood Department. Other key measures, such as cords of wood per jib crane bite, were found to be off by 43%. These were corrected, as was the chip measurement system, which consisted of a weightometer reading that we frequently tried to run above its calibrated range. Upon completion of this step, we were then able to work through the remaining steps fairly quickly. Step 4, is the process stable? A run chart on the daily groundwood matrix was analyzed for length of run, trend test, and number of runs. The run chart passed all 3 tests, therefore the process is stable. Step 5, local workforce identifies special causes. Since the process was determined to be stable in Step 4, no need exists to identify special causes, and the team moved on to Step 6. Step 6, address identifiable, cost-effective sources of common cause variation, otherwise known as the gimmies.
Hello everyone, I'm Don Moses. In Step 6, the group found that just starting the task force raised awareness and resulted in a reduction in the amount of groundwood needed to support the process. We created a more accurate means of measuring the amount of chips going to the chipper. to the chip pile by widening the range on the weightometer. We found out the grapple bites on the jib crane are really 17 cards versus the 12 cards we had been using. We also raised the upper diameter limit from 10 inches to 14 inches to reduce the amount of quality wood that was going to the chipper. As a result of the big night out, the group made the decision to try an experiment in the wood yard. Since the results thus far had shown that the sorting of the groundwood in the wood yard actually decreased the number of sticks that met current groundwood specifications, and the specifications the wood yard was sorting to had no detrimental effect on quality to the groundwood mill. We made the decision to plow 100% of the wood flow to the sorting table and no longer use the plow as a sorting point. This experiment started on December the 19th, 1991, and continued for approximately 2 months. The only criteria on the sorting system consisted of any forked or crook sticks, any stick with knots 2 inches to 3 inches or greater in length, any stick with a large area of bark, and any stick larger than 14 inches in diameter. The results in the woodyard running experiment were the groundwood quality wood usage reduced by 2,500 cards per week. Groundwood quality wood to chipper reduced 200 cards per day. The results of the experiment in the groundwood mill were no reduction in unbleached brightness, no quality loss due to cat faces and knots, and no increase in shives due to broom ends.
Step 7, capability. With a process that is stable, along with enough data that represents all sources of variation and a histogram that indicates a normal distribution, it is possible to statistically determine whether or not the process is capable of meeting current specifications. These criteria were met, so our next step involves calculating the process capability indices, or CPKs, on those key measures for which we have specification limits.
The capability of the groundwood mill to produce quality pulp, as measured by the key measures of mullen and tear, increased after the formal experimentation, which we will discuss later. The variability of mullen decreased from 0.75 to 0.52, and the capability index increased from 1.27 to 1.84, while the mean remained basically unchanged. The variability of tear decreased from 1.92 to 1.46, and the capability index rose from 0.80 to 1.15. Again, the mean remained basically unchanged. Unbleached brightness results decreased from pre-experimentation levels, but still remained within acceptable limits. Variability increased from 0.49 to 0.56, and the capability index decreased from 1.96 to 1.52. After experimentation, the process is fully capable of meeting mullen and unbleached brightness specifications and is marginally capable of meeting tear specifications. Prior to the experimentation, the process was not capable of meeting tear specifications.
Step 8, the 2x2 experiment and the design of experiments. In late January and early February, the task force designed and executed a 2x2 factorial experiment in the woodyard. One of the main goals in performing this experiment was to acquire the discipline needed to conduct a larger experiment later in the process. The objective of the 2x2 was to find those factors that are most important by pushing the characteristics to their extremes. Here's Stuart Martin and Ward Crow to take you through Step 8.
The two factors that the task force chose to experiment with were the age, or freshness of the wood, and the quality of the wood. The perception had always been that older wood reduced unbleached brightness, a very important quality characteristic of groundwood pulp, and that only high quality wood could be used to produce high quality groundwood pulp. Top wood historically had been manufactured into chips for use in the linerboard production because it was considered to be too knotty and rough for groundwood. For the 2x2 experiment, we ran tops only, quality wood only, and a 50-50 mixture of both. And we varied the age of the wood from 0 to 12 days. The variables that were measured included unbleached brightness, mulling, tear, freeness, and grounder downtime. The only response variable that was impacted at all by the wood mix or the wood age were freeness and grounder downtime, and these effects were only negligible. There was no significant impact on any of the other variables. Performing the 2x2 experiments taught us several key lessons. Perhaps the biggest one was that it takes a lot of discipline from everyone included. And also that communications between everyone involved in this is extremely important. We also found that there were safety and manpower issues that came along with running 100% top wood. And for these reasons, we decided that we cannot use all top wood for groundwood production. After completing the factorial experiment, the group performed an appraisal of the first 7 steps of the 8-step procedure to ensure that we were truly ready for the execution of a full-scale 8-run placket Berman design experiments. After determining that we were ready, we began the experimental design by brainstorming the experimental factors and the response variables that we felt were significant. The long list of factors were reduced by considering each factor in terms of whether it was practical, feasible, and cost-effective. Any idea that did not meet these criteria was scratched from the list. Minimum and maximum conditions for each factor were selected, and the order of experimentation was randomly determined. The factors that we selected were wood freshness, percent of high-quality groundwood volume, whether we sorted on the groundwood table or not, and whether we slashed longwood with a slasher or not. We also had to include 3 dummy variables so that the factors would fit into the standard placket Berman matrix. Each treatment combination was conducted for an entire groundwood run each day and evaluated in the groundwood mill the next day. Data during the experiment was collected in both the woodyard and the groundwood mill. In addition to the response variables, suspected covariants such as weather conditions were observed and noted. Although the actual experiment was performed in 16 days, it took several weeks to complete the experiment to ensure that we had proper inventories of fresh and old wood. And the results of our DOE showed us that there was nothing at all in the wood mix or the preparation of the wood that significantly impacted either positively or negatively the quality response variables.
Thank you, Stuart. After closing the plow in December and running the total flow across the groundwood sorting table, a couple of new problems were experienced in other areas of the woodyard. By sending all of the wood to the sorting system, no wood went through the chipper except for rejects. The drop in manufactured chips during the groundwood run dropped chip pile inventories, resulted in a lower chip quality matrix, and caused additional bridging in the chip tunnel, which slowed chip feed to the craft pulp mill. As a result of these problems and the findings of the task force, we decided to utilize our experimental data and run a 50% groundwood and 50% tops mix during the groundwood run, while the pile is operated to feed both the sorting system and the chipper. Operating under this method allows the woodyard to realize the savings from using less groundwood and also feed the chip pile as required by the craft mill.
Our conclusion, results of histograms, groundwood pulp quality, groundwood usage, and our cost savings.
Hello, I'm Tommy Linder, and for the next few minutes we'd like to discuss the results and the conclusions of the Groundwood Optimization Task Force. The resulting changes made by the task force had no detrimental effects on groundwood pulp quality. Unbleached brightness, mulling, and tear showed very little change after the process changes. Here are some key measures that were virtually unaffected by the changes we'd like to show you in the form of a histogram. Our first histogram is of groundwood unbleached brightness. As you can see, the average before we started the task force was 58.88. The average after that was 58.56. Standard deviation was 0.49, and it moved to 0.56, which is a very insignificant change. Pulp mulling also, as you can see, a very similar situation here. Before the task force, it was 10.22. After it was 10.37. And again, the standard deviation changed from 0.75 to 0.52. Groundwood pulp tear. Also, we have a 25.39 average before, and we moved to a 24.95 average after, with very similar changes in, or very minor changes in standard deviation. Even though we had some very significant or insignificant changes in groundwood pulp quality, we did have a very major change in the amount of groundwood used per day. As you can see by the graph, groundwood went from 946 cords per day before the task force to an average of 638 cords a day after the changes were implemented. As you can see, our process tightened up and also moved to the left. Variation was also reduced, as indicated by the standard deviation, going from 314 before the study to 268 after the study. The decreased usage in high-quality groundwood didn't occur all at once, but in several stages. The first stage occurred before the big night out. The usage was reduced from 6,622 cords per week to 5,816 cords per week, a difference of 806 cords. This reduction mainly occurred out of awareness and just looking at our process. The second stage occurred after the big night out and was mainly due to an experiment where we ran with the plow closed. We also started culling fewer sticks based on actual defects that we previously thought might cause problems in the groundwood mill. Now, the last stage of reduction is the period that is going on right now. Over the last few weeks, our usage has been reduced by another 600 to 700 cords per week, mainly because of our continued understanding of how our process works. We are now running a 50-50 mix of high-quality groundwood and tops during our groundwood run, which has resulted in this new reduction of high-quality groundwood usage. So what does this reduction in high-quality groundwood really mean to Boise Cascade? Well, based on cost information that we have collected since the beginning of this project, we estimate conservatively that we'll have a savings of 100,000 cords at $16 a cord for a $1,600,000 savings. And the reason that we say this is conservative is because of the potential savings that we have not claimed any credit for. The first one of these is the additional 17 tons of groundwood fiber being produced this year as compared to last year, requiring more groundwood sticks. Lower working capital due to reduced timber deed level. No savings have been claimed for reducing airport woodyard activities, which include such things as double handling. The extra cost associated with the extended wet weather conditions, which necessitate additional procurement. The potential savings changes in procurement strategies and expanded procurement options. Continued reduction in groundwood usage as we optimize a new recipe for running groundwood. Based on how these particular savings are utilized, we estimate a $2.2 million savings annually could be achieved.
We'd like to thank you for your interest in watching this video and thank the company for providing us with the tools, the resources, and the training to accomplish what we did. We're excited about our success and hope this is of interest and will benefit you in pursuing total quality in the future. Thank you very much.